Hello folks, and welcome to the EV-BMW Christmas special for 2018. So, before we get started, let me wish all of you watching this a Merry Christmas and a Happy New Year. And thank you for following and supporting my crazy channel. Right, now, so you might be sitting there thinking, what EV related topic are we going to cover in this special episode? And the answer is none. But we are going to be covering a topic on power electronics and dangerous things, which, you know, I figured, why not? I did also get a comment on one of my latest land yacht videos there saying that some of you missed the days of the molten spanners and things like that. So this could all go bad too, so there could easily be molten components. Anyway, some of you who follow me on social media may know over about the last month I have had some flooding problems. About a month ago, this very workshop where we're sitting flooded to about 2 inches of deep, 2 inches of depth water all over the floor. Now, I'm not going to get into the whys and the wherefores of it, only that we needed to fix it and fix it fast. So, I proceeded to dig over a 1 meter deep sump just behind me here at the back of the shed, and I sunk a 2-foot diameter concrete pipe vertically into that sump, and the purpose of that was to allow me to put a submersible pump in there that would, when the garden attempted to flood, this would be the first place that the water would go, because it's the lowest point in the entire area for, sod's law reasons. And the water would go in there, the submersible pump would trip on, and it would pump that into a storm drain. So, cool. My first attempt featured a little pump that I purchased online that was supposed to do 300 litres a minute, and I thought, wow, that should be more than enough, 300 litres a minute. So put this in, and very next day, Floodsville. Flood. And the pump's running and it's pumping, but it's not making a dent in it. So I thought, okay, if one pump is good, 2 pumps have to be better. Got myself a second pump and upgraded the discharge hose from 1-inch PVC to 2-inch lay flat. So now I've got 2 2-inch hoses pumping out at allegedly 300 litres a minute each. You guessed it, next day, Floodsville. And both pumps are still on, but they're not making a dent. Right, okay, I said. 2 pumps can't do it. How about we get 3? So I get a third one. And another length of 2-inch lay flat holes, and we put them in there. Next day it tried to flood, and it kind of got a bit. It didn't manage a full flood, and the pumps just about held it back. And that's where things have been for the last few weeks. When a flood tries to occur, the pumps just about manage to keep it back, but they ain't gonna last. And all it would take would be a slightly heavier rainy season, which of course we never get here, to cause the pumps to be over capacitated. So I looked. Around at a bigger pump, because when a job doesn't go right, more power, okay, is what we need. And I got myself two rather kick-ass pumps. I've got myself a Grindex submersible pump in there, which we'll see in a minute. That's supposed to do, I think, 700 litres a minute, and I've got a Grundfos one that's, I think, 600 litres a minute. And I got those second hand very, very cheaply and in very, very good condition. But there's a slight complication. They're three-phase pumps. And we've only got single-phase power here, being a domestic dwelling. We don't have three-phase power. Now, that's a bit of a problem. So I figured I'd work something out, and I've messed about over the years because I've got machines here, you know, lathe milling machine and things, and I've messed about with capacitors and transformers and relays and contactors and all, and yeah, they'll work. But I've found that, you know, the bigger motors don't quite work too well, and they never have the kind of power that you need, and so on. So, bunch of you guys had been saying to me when I was messing about with the Prius inverter here, could we use the Prius inverter to generate mains power? And I think the answer to that question is going to be yes, but I needed two things. I needed a proof of concept, and I needed it quicker than it's going to take me to do all the engineering work on the Prius inverter. So I thought, okay, what if we get an industrial VFD and we mess about with it? So I did some research online, and I found a very good YouTube channel by a chap in the UK called Dino Guy, and I'll try and put a link in the description to that. And he had a few videos on there where he has modified 400 volt VFDs to work as kind of three-phase power supplies. So I thought, okay, I wonder, could that work? And I mean much to my surprise, not only does it work, but it works very well indeed. So this is the Christmas special, guys. We're going to show you how to make three-phase power with a cheap inverter, so that you can run pumps, so that you can avoid flooding and other things. Like even my power hacksaw runs, and I haven't ran the power hacksaw in I don't know how long, 5-6 years. So let's go have a look. Alright, now my workbench here is of course the usual mess with our Prius inverter that we're working our way on, but over here this is this is about a day's work here. Now what we've got is a Vacon 11 kilowatt variable frequency drive. Very, very standard things used for speed controlling electric motors in all kinds of industrial applications. This one is basically brand new. It even had the plastic cover over the keypad. Got it on eBay, including shipping, for less than 200 euros. Now, I actually found that I think some of the bigger inverters tend to be cheaper because people kind of, you know, they're not something that people can run at home, and industrial users tend to buy new from a source that's going to give them a warranty and things like that, rather than just eBay. This one, as they all are designed to run from a three-phase 400 volt input that would normally go in here on L1, L2 and L3. Now I'd been messing about just with a transformer, putting 400 volt single phase in there, and that actually worked quite well. I could run the stuff I wanted to run and that with it. But basically, just in case you think I'm fooling you, that white cable is plugged out. Now it's not, that's not doing anything. So basically, yeah, if what the Dino Guy showed was that you basically step up your 230 volt single phase to 400 volt single phase, feed that into your inverter, turn off the phase failure detection, set the thing to run 50 hertz, and you're all set. And then that indeed did work. But I figured, is there a way that we could avoid needing a transformer? Now, again, a lot of the bigger inverters are designed to run, as well as run from AC, you have access to the DC link here. So you'll see there's a B minus and a B plus terminal. And these two brown wires that you see here are going all the way over here, and they're going into this mess. And this mess is being fed by this white cable here, which if we follow it all the way back over here, is just going into a 13 amp plug and into my Variac. The reason I'm using the Variac is it lets me increase the voltage slowly in case something explodes. So this is for testing. You could just basically take that and plug it straight into the mains. So, what is this mess that you see here, comprised of a rectifier and two large capacitors and an extremely sketchy and dangerous setup? Do not do this at home. You have been warned. If the electricity does not kill you, I will. Now, what this is a device called a voltage doubling rectifier. So it's doing two jobs. Whereas a normal rectifier simply converts AC into DC. This guy converts AC into DC at twice the normal DC voltage. So what this means is that when we crank up the power here, we're going to see on the multimeter about 650 volts DC being generated from our single phase 230 volts AC. That is going to be fed into the DC link of the inverter, which is then going to say, I've got enough voltage, and then we're going to press the old start button. It's going to make 50 hertz power, and then we're going to go crank up the beast, which is the milling machine. And the milling machine is a machine that I never really was able to successfully run with capacitors and those kind of converter things. Never really liked it. It did run, but just was not happy. And part of the reason for that is it's got three motors in it. It's got a main spindle motor. It's got a drive motor here for the axes, for the X axis. It's got a little coolant pump motor in there as well. So that's a 4 kilowatt motor, which is the biggest one that I've got in the whole place. So I figured if it can start this, it can start anything. So enough talk, let's go crank it up. So right now DC link is at pretty much 0. So let's go have a look. Let's go have a look. What we're going to do, I'm going to turn on our switch here, and I'm going to bring you guys over here. I'm going to reach around and get the old, here we go, increasing the Variac. Voltage is coming up. You can hear the inverter starting up. We're now at 100% on the Variac, which is 230 volts AC input. We're getting 655 volts. Our multimeter's gone asleep, of course. Yeah, fantastic design. So right now we're taking just under half an amp AC, well about 0.3 amps AC just idling. We're gonna just get rid of all this crap. Start the inverter. So right now I've got this set up so that it's always making 50 hertz power. 50 hertz, 400 volts. This thing here is just a line filter that I was experimenting with. You probably don't need it, but I just got this along with it to try to take out some of the switching noise. So right now the output is coming out, going through the line filter again, which, as I say, you really don't need. You could just come straight out here, coming out through this black cable, and is going into our milling machine plug here. So here's the main spindle, and here's me starting it. That's the main spindle on, taking 4 amps at 400 volts. We're holding 622 volts on the DC link, and we have 8 amps of 230 volts power. Go ahead. Auto feed motor working. That's the automatic feed motor working, as well as the other one, the main spindle. 8.8 amps and 622 volts on the DC link. You can pretty much treat that like a 3-phase power supply. You just kick the switch, machine starts up. And that's it, folks. And I suppose might as well, to finish off the demonstration, show you it running a few more things. So got my Grundfos pump here. Let's go grab the cable. Unplug the milling machine. Here's our Grundfos pump. So I'm just going to direct start that. Pump's on. About 1.3 amps at the minute. It's running unloaded, so run that. And our power hacksaw. Just starts straight up. We're 1.4 amps, 637 volts on the DC, and 4.6 amps on the way in. I tested this yesterday, cutting through a 3-inch solid bar. So yeah, there you have it. Stop that. So folks, there you have how to make 400 volt 3-phase power using a off-the-shelf VFD, 2 big high voltage capacitors and a big high voltage bridge rectifier. And this stuff is absolutely perfect. I've had the differential probe on it there. It's, you know, you get sine waves. It's, you know, 120 degrees apart, doing what they should do. Now, our next phase, if you'll pardon the pun, in this operation will be to try to get the Toyota Prius inverter to do this for us, using a Hubner brain instead of, you know, just some random VFD. But that is it. I hope that 2018 was a good year for you. I also hope 2019 is going to be a good year for you. And thank you again for all of the support. And we will see you back in the new year for some regularly scheduled EV madness. And we have some good projects for 2019 and some interesting, you know, changes going on to the system that will hopefully make for some better programming also for you. So that's it. I leave you at that. Don't forget to like, share and subscribe. Check links in the description for various things: GitHub, PayPal, Patreon, forum, and whatever else I can think to put in there. Until next time, happy three-phase inverting.